Hello everyone, myself Vanitha Lakshmi K. Today I am going to present a topic of smart glasses for blind peoples. Our group members are Prarthana P, Priya R, Sandhya V R, Raksha NG. Our project guide is Shweta DS. These are teammates. The contents are introduction, problem statement, literature survey, objectives, software and hardware or requirements, methodology, software or implementations, software and hardware specialization, and conclusions. Here is the introduction. They uses the technologies like AI, computer vision, sensors, and voice assistant to understand the surroundings. These classes can detect the obstacles, recognize the objects, read the text aloud, and even identify the faces. Means these glasses are designed to help the blind, visual impaired peoples. They uses the technologies like sensors, AI, and cameras to understand the surroundings. The glasses can detect the obstacles, recognize the objects, and read the text aloud. And their main goal to improve the safety, independence, and confidence while moving the around. Users can navigate the unfamiliar environments, access writing of informations, and perform the daily task more easily. These glasses reduces the need for continuous human help and promotes the self defendence. Means the main aim is to help the users move safely, independently, and confident in daily life. They help the enhanced quality of life and supports the equal participation in the modern society. Next is the problem statement. Blind and visual impaired people faces the difficulty in independent mobility and navigations. Traditionally, aids like white canes and guide dogs provided the limited environment informations. Means blind and visual peoples find like a difficult to move around independently. Traditionally, tools like white lens and guides dogs gives the limited informations. They cannot detect all the obstacles, especially moving or head level objects. So difficulty in identifying the objects, reading test and recognize the peoples in real time, increasing the risk of accidents and safety issues in unfair environments. High dependency on others for daily activities and outdoor movements. Lack of real time feedbacks around surroundings reduces the confidence and independence. Need for a wearable and hand-free assistive solution that provides the accurate and timely guidance. Means it needs a smart hand-free and the solution that gives the real-time guidance and improves the safety and independence for the um, blinded people's. Requirements for smart glasses that uses the sensors Adino Uno, buzzer, IR, ultrasonic sensor, and the glasses intelligently processing to give audio and haptic feedback for safe and independent living. So this increases in everything uses the sensors that will give the safe feedback to and independent living for blinded peoples. The next slide is continued by Sandhya.
Myself, Sandhya VR. I am going to explain literature survey. First, title of the paper: Smart Glasses for a Blind People Using IoT. In which year? Uh, 2021. Author name Dr. S. Ramesh A. Kumar, and the technology adopted is IoT sensor, ultrasonic, obstacle detection, voice assistant. Second one is assistive smart glasses for visually impaired using Raspberry Pi. In the year 2020, Priya Sharma N. Gupta, technology adopted is Raspberry Pi and camera module, image processing, audio feedback. Next one is AI based smart glasses for blind people in the year 2022, and the author name is M.J.K. Patil. Technology adopted artificial intelligence object detection speech text module. Fourth one is voice controlled smart glasses for a blind navigation in the year 2023. Author name is R. Meena and T. Varun. Voice recognition and GPS navigation, ultrasonic sensors. Next one is objectives. In the objectives sphere includes that detect obstacles using ultrasonic or IR sensors, and provides real time audio or vibration alert, identify objects, peoples and text using AI and OCR, and assist outdoor navigation using GPS and voice guidance, enabling voice control for a hand free use, design a lightweight, low cost, and user friendly system. Next slide. Here we are include software and hardware requirements. Software requirements are Arduino IDE. Operating systems are Windows 7 or any compatible. Editor Notepad. Hardware requirements are processor, Arduino Uno, IR sensor, power supply in 9-volt battery, buzzer, jumper wires. Next slide will be continued as the Raksha NG.
Hello everyone, myself Raksha NG. My topic is methodologies, requirement analysis in identify users' needs such as obstacle detection, navigation assistance, choose an appropriate components. Next, IR ultrasonic sensors, microcontroller, vibration feedback. Obstacle detection. The system must detect object in front of the user. Navigation assistance. It should help to user move safely by giving alerts. Component selection. URL ultrasonic sensors to detect obstacles. Arduino Uno acts as the brain. Vibration motor buzzer gives alert feedback. System design. Establish hardware connection between Arduino sensor buzzers vibration motors. Arduino is connected to ultrasonic sensors, buzzer or vibration motors. Power is supplied using battery or USB. Signal flow from sensors to Arduino to alerts devices. Next slide. System works like power source development system workflow sensor input Arduino processing alert output block diagram flowchart and operations working flow sensor sends ultrasonic waves it an obstacles and return Arduino calculates distance if obstacle is close alert is activated the flow usually showing as blocking diagram or flowchart front front end and the back end development front end user interaction through voice feedback or vibration alerts back end Arduino programming for reducing sensor data detection obstacles trigger buzzer flowchart explanation start trigger ultrasonic sensors read echo signals, calculated distance, obstacles, activated buzzer vibration. Front end user experiences vibration, alerts, sounds, and voice feedback. Back end reading sensors, data, calculation, distance, checking obstacles, conditions, activated alerts. Software implementation. Next slide. Software implementation. Duration, it means time taken to echo to return. Distance, calculated the distance obstacles. Setup function, wired setup. Wired setup, pin mode, trig out point, pin mode echo input, serial begin 9600, sets the sensor pins, start serial communications. Loop function. Loop function means sends ultrasonic pulses. Next, calculates distance using the speed of sound. Next slide. Display distance and serial monitoring. If distance below the set limit, buzzer on, else buzzer is off. Overall working is the ultrasonic sensors detects obstacles, Arduino calculates the distance, and if an object is close, buzzer or vibration alerts once the user. Next slide will be continued by Prarthana P.
Myself Prarthana, I am going to explain about the topic software and hardware specification. Arduino UNO. Arduino UNO acts as the brain of the smart glass. It controls all sensors and output devices. It processes data and gives alert to the user. It works automatically when the power is on. It acts as a central controller of the smart glasses, receives input from ultrasonic or IR sensors, processes distance data using the programmed logic, controls output devices like the buzzer, automatically start functioning when power is supplied. Next slide. IR ultrasonic detects nearby obstacles like wall, person, vehicle, pole, etc. Measures the distance between the user and the object, sends distance data to Arduino UNO, helps in accident prevention, makes the glass smart and responsive. Our IR ultrasonic sensor continuously scans the surroundings for obstacles, detects objects such as walls, people, poles, and vehicles, calculates the distance between the user and obstacles, sends real-time distance values to the Arduino UNO, plays a major role in accident prevention and safe navigation. Next slide. Buzzer gives audio alert to the blind user, warns when obstacle is near, indicates danger situation, helps user change direction, acts as a sound output device. It acts as the main audio feedback device, produces warning sound when an obstacle is detected nearby. Different alert patterns can indicate different danger levels, helps the blind user understand when to stop or change direction. Next slide. Glass acts as a platform to mount sensors, cameras, and electronic components, holds cameras or sensors to capture the surroundings, provides protection to electronic parts from dust and damage, ensures comfortable and wearable device designed for long-term use, serves as the variable structure for the system, provides proper placement for sensors and electronics, protects internal components from dust and minor damage, designed to be lightweight and comfortable for long-term use. Next will be continued by Priya.
Myself, Priya. My topic is USB cables. Power supply. Provide the electrical power to the Arduino Uno and other electronic components used in the smart glasses, and data transfer transfers the data between the smart glass and the system in the computer for a programming and firmware updates, and charging. Used to charge the rechargeable battery integrated to the smart glasses, and debug the programs, and helps to upload the code to the microcontroller. Next slide. Next slide. Jumper wire. Electronic connection is used in jumper wire, used to connect the different components such as sensors, Arduino Uno, buzzers, and extra, etc. Flexible prototyping allows the easy setup, testing, and modification of the circuit without soldering. Signal transmission carries the powers and data signals between the microcontroller and sensors. Components integration helps in integrate to all the electronic parts on the PCB for a smooth and proper function. And these jumper wares are usably in all the fields. Next slide. Conclusion. Here, our smart glasses are involved in the assistive technology and designed for visual impaired individuals. The system aims to improve the mobility and safety and independence in daily life. It is use cameras, sensors, GPS, and AI to understand the surrounding environment. The smart glasses can be detected the obstacles, recognize the object, and read the text, identity, and the surroundings. It provides the real-time audio or a vibration feedback to the guide of the user safety. This reduces the dependence on the other helps and user to move confidently. The smart glasses act as a digital eye to convenient visual information into audio or the textile signals. Overall, it enhances the accessibility, safety, and equality of the life for visual impaired people. Thank you, everyone.